wanted to see how much of set theory, or how much of the set theory I know, which is very little, I could recreate in Scratch, which is a relatively rudimentary problem. Now, of course, Scratch already has elements of set theory incorporated because programming is logic, and logic is basically founded on sets. So, that said, it's not very impressive that I was able to recreate it. However, I would like to think that there is some novelty in the way I did it. I realized that the list function is already a rudimentary sort of set, even though it really behaves more like a duffel bag than an actual set. But we can add things to it. I added this little numbering system so that you can keep it the no duplicates rule. Before I knew about the no duplicates rule, I made this, which will just shove all the elements of both sets in without preventing duplicates like that. And as you can see, we've got duplicates. However, this is number one, incredibly clunky, and number two, not sets. So then I was like, okay, these lists can only be finite sets, but let's just have like the union of two finite sets. So, and here's how I did that. I was like, in plain English, if the nth item of a set isn't already there, add it. If you're already done with number one, here, move to number two. Otherwise, here are instructions for number one, and those for number two are basically the same. We can already have sets just by defining them, and these don't need to be finite. For example, we can test if something's a member of the set of all integers. Here's an integer, and then here's not an integer. And the OR function is, by definition, almost the union of two sets. No, it is by definition the union of two sets. So we can pretty much automatically use it to say, like, is this a member of the union of the sets of multiples of 3 and multiples of 2? And we can do that here, which should be z. Okay, let's input 3. It's a member. Input 2. That's a member. Input 6, which is a member of both. That's a member. And let's input 7. Sorry. Is not a member. There is a... okay. There is an argument to be made that what we've done here is absolutely useless. Why would I be playing with lists that are more like duffel bags than proper sets? My answer? Give me one good reason why not. Also, using a system's own function to recreate a part of that system is the same as just using that function. There's no point in it, but if you can actually get the system to do one of the things it does without actually telling it to do that thing, that's when things get interesting. And if you can kind of create the input system with the outputs. I don't know. I don't really understand it perfectly, but this is just about all I was able to recreate, and I really hope that I've done anything. I really hope I've done something here.